Okay, hello again. We're going to talk about transformers and the transformer laws. Now, our transformers, we technically have 3 types of transformers, but when it comes to the transformer laws, we're really only going to care about 2 of them. The 2 transformers we really care about are going to be our step up and our step down transformers. So we have a step up transformer, and we're going to have a step down transformer. So what is a transformer in general? A transformer in general is going to be something that is going to help us change our voltage whenever we are making the X-ray machine work. Both of these are going to change the voltage by either increasing the voltage, which would be our step up transformer. It's going to increase our volts. And our step down transformer is going to decrease our volts. Why would we want this to happen? Well, if you remember from lecture 1, I said that our voltage is going to be what is responsible for making our anode more positive. If you remember how we talked about X-rays working, we have our cathode side of the tube and we have our anode side of the tube. Well, our voltage is going to be what makes our anode more and more positive. So then all of these electrons that we get over here on the cathode from the filament, when this filament gets really, really hot, if you remember what controls the filament is going to be our current. Our current is also going to be controlled by these transformers. Whatever happens to our voltage is going to be the opposite of what happens to our current. So in this case, if we have a step-up transformer, we would expect our voltage to increase from one side to the other and our current to go down. On the opposite end of a step-down transformer, if our voltage is going down, we should expect our current to go up. And what does our current control, or what controls our current? Our mass. Why do we need current in general? Well, current is going to be what controls that filament. Current is going to be what gives us our source of electrons, and our volts are going to be what makes the anode more positive or more enticing for those electrons to go over to the anode of the X-ray tube and then eventually give us our X-rays. I want to make sure we can see all of that. How far down can I go? Right there. Okay. Sorry, you guys are, I have you situated up on a box, so I'm trying to see what we can see. Okay, so I said we have a step down, a step up, and a step down transformer. So first thing I'm going to do is I'm just going to draw you a transformer and draw the difference. So our transformers look like a little arch almost. Whenever we see them on a test, whenever I expect you to know what they look like, they're going to look like something like this. I don't like to do the big box because it messes with my drawings and I don't like it. So it'll either look like that box or it'll just look like the arch I got going here. So I said we have 2 different types. The purple one here, I guess I could have drawn that purple, so let's do that. Our step up transformer. So you guys haven't had me before, but one of the number 1 rules in my class is don't make fun of my drawings because I can't draw. That's as good as it's going to get. So our step up transformer. Our step up transformer is going to look like this, and it's going to have windings on it. What are our windings and what do they do? Well, our windings are going to be like these little loops here. Like that. They might look like, I guess I should have made that. Ignore this for half a second. This isn't happening because this is a step-up transformer. So our step-up transformer, it's going to have these loops or windings on one side, and it's going to have the same exact thing on the other side. Now, What is the difference here? These windings here are going to be what conducts our voltage. This side here, if you can't tell, has space in between the windings. That means there are less of them. So this side is going to have, this is our primary side, by the way, our primary, and our secondary side of our transformers. It's always going to read the same way. This side is primary, this side is secondary, regardless of how many windings are on either side, because if it was a step down transformer, it would look a little bit different. The left side, if you're looking at it, is always going to be your primary, and your secondary side of your transformer is always going to be the right side. What tells us if it's a step up or step down transformer? Besides the voltage in general, if we don't have the voltage, how could I tell this is a step up transformer? Because of the way these windings are drawn. So this side here, these windings are a little bit more spread apart. They're not as close together, meaning there are less of them. This side has a lot more windings. They're closer together. If a side has more windings on the secondary side, which like this one is, this is a step up transformer. Now, aside from the windings going up, what else could I expect to go up in this transformer? What we care about, our voltage. So let's say on this side of our transformer, we have 1,000 volts. And on this side of our transformer, we have, let's say, 20,000 volts. What happened here? My voltage went way higher. So we stepped up our voltage. Our step up transformer is going to be in the upper portion of our circuitry. It's going to still be in the high voltage section because we're working with high voltage. And this is going to be what supplies our voltage to our anode. And that anode would become more positive and attract all of those electrons over from the cathode. But regardless, our step up transformer is going to allow our voltage to go up. If I'm looking at just a diagram, I can't see my voltage here at all. What would I see? I would see more windings on the secondary side than the primary side. That would tell me this is a step up transformer. Now, the thing with volts and current, if one goes up, the other has to go down. Why is that? Because if we also increased our current, it would probably short circuit the whole system. I'm not actually an electrician, crazy, but that's my general assumption. So whenever we see our voltage going up from one side to the other, we should notice that our current would go down. So let's say on this end we had 12, let's see, that went up by 20. Let's say over here we had, we'll do the opposite. Let's say we had 20 amps. Amps is the same thing as our current. It's going to be an A. Our amperes. We say milliamperes. So let's say our current in the brown here is 20 amps. If our voltage went up, we should expect our current to go down. So let's say we went to 1 amp. Oopsie. Just 1 amp here. So our voltage goes up, our current goes down on a step up transformer. And then we had a third little guy. His name was power. Our voltage and our current together are going to make our power. So if our power over here was power, would be our voltage times our current, which would be 20,000 on one side. The power does not change. So this would be 20,000 on this side. The combination, again, of voltage and current is still 20,000. The combination of voltage and current over here is 20,000. Why does that matter? Well, just like you don't want your power overall in your house to flicker, we don't want our power to change as we're working with our voltage and our current for our powering of the X-ray machine. So this example here is a step up transformer. What do we really, when we're talking about step up and step down, what's the first thing we are referencing? The voltage. Secondary to that, whatever we do to the voltage, the opposite would then happen to our current. Now, I know I went over this in class, but some of the classes I didn't get to spend as much time as I wanted with it, so I wanted to break that down. This is an example of a step up transformer. Now let's draw a step down transformer. So I'm going to make it green to show us this is now a step down transformer. Our windings. If we're stepping down our voltage, that means my voltage, purple, our voltage on this side, before we even make our windings, is going to go down from our voltage over here. And what we just said, based on this principle here, if our voltage is going down, we would expect our current to go up on the secondary side of our step down transformer. So I'm going to draw our windings. These ones are going to be really close together over here. And then over here, we might get a few. So let's use those same numbers again. Let's say over here on our primary side, our left side, no matter what. Now before, we had more windings over here. We have more windings on the primary side now. So let's say that we had 20,000 volts on this side, and we had 1 amp of current. If our voltage is going to go down, let's make that the first thing we work with. Let's say that now we have 1,000 volts over here. Oopsie, let me move this. So 1,000 volts here. So our voltage went way down from where it started. So if our voltage went down, our current should go up. So let's say our current is now 20 amp. I used the same numbers because I was being lazy and didn't feel like doing math to figure out new numbers for my power. But regardless, even if these numbers were different, so let's say we did, I don't want to do the math, to be honest. I don't want to do it. But let's say that these were different numbers. Regardless of what they are, our power from one side should be the same to the other side. So whenever you are asked on your test, what happens to the power if we change from a step up to a step down, or if we went from more windings to less windings, what happens to our power? Absolutely nothing. Your power should always be equal from one side to the other. What is actually going to change is, number one, our voltage, and whenever we change our voltage, we have to change our current. So whenever we are asked, what would happen to my current on a step down transformer? Okay, a step down transformer. Well, I know on a step down transformer, my voltage goes down. So if my voltage goes down, my current has to go up. So sometimes you might be asked what happens to the current. Sometimes you might be asked what happens to the voltage. And you might be asked for a step up or a step down transformer. It'll say from the primary to the secondary side, what can you expect from any of these scenarios? Now, all of that being said, we have a little bit more math to do. We have something called transformer laws. So just like the inverse square law, where we were trying to figure out what would be the new intensity of our X-ray beam if we changed our distance. What could we potentially be changing here with our transformer laws? Well, we could be trying to figure out if we go from if we have a step up or a step down transformer, what's changing in the voltage. We could also figure out what's changing in the current. Or we can also figure out what changes are there in when we have both current and voltage in the problem. Okay, so our first one is going to be voltage. So I did purple earlier for voltage. So let me erase this guy because we don't need him. And let's work on voltage. I just spelled voltage. That's cute. I'm educated. Our voltage. Now our voltage formula is going to be Vs over Vp equals Ns over NP. Now on your PowerPoint, you also might have one where these are upside down, where it is, let me see here, on slide 62, it actually has your P's on top and your S's on the bottom. This one is a direct law, so it doesn't matter. Like, this is the exact same thing as Vp over Vs equals Np over Ns. As long as your S's are either both on top or both on bottom, and your P's are are where they're both on top or they're both on bottom, it's okay. This one, it's an equal situation. So this, whichever one you use, will work for voltage. I'm going to use this one right here. Now, in your PowerPoint, it says that Vs stands for your applied voltage. I'm sorry, your P. Your P stands for applied voltage, but I like to call it your primary voltage. So Vp, I'll bring this over a little bit closer to make sure I have enough room to write. So Vp is our primary, because it's going to be on our primary side. Our Vs is secondary. It'll be on our secondary side. Sometimes that's what we're solving for. Our NP is the number of windings on our primary side, and our NS is the number of windings on our secondary side. So this is if we are trying to find the voltage. In the first problem on slide 63, this one works itself out for you on the PowerPoint, but it uses the opposite way, where the P is on top and the S's are on the bottom. But I'm going to show you here, even if we use the S's on top, it's going to work out. So our Vs, I'm sorry, I should read the problem. So it says, if a transformer has 10 times as many primary windings as secondary, what type of transformer is it? And if 110 volts are applied, what is the delivered voltage, or our secondary voltage? Secondary also means delivered, and this also means applied. But I like to use primary and secondary because they match up with the actual letters. So, first things first, whenever I'm doing a transformer law, I like to draw my transformer. I like to draw what it's saying to me. So in this case here, it says if a transformer has 10 times as many primary windings as secondary, that means it's going to have 10 times as more. So I would expect it to have a lot more windings over here than over here. So if I have more windings here on my primary side versus my secondary side, that means there's a higher amount of voltage here than here. So this is going to be a step down transformer. So it's a step down transformer. That's the first thing I like to do. I like to draw it out so I can see for sure, okay, all right, what I'm looking at. Now, what we're looking for is going to be our secondary voltage. It's asking what our new voltage would be. So if we know it's a step down transformer and we have higher amount of voltage on this side than this side, we should expect our number of volts to go down. The numbers they gave us here were has 10 times as many primary windings. Sometimes the question might say something like that, or it might say if there are 10 windings on the primary side. So our NP is going to be 10. 10 times as many. If it doesn't actually give you a number, if it says something like that, if it's 10 times as what? How many? It would just be 1. So you can either say like 10 times as many, 20 times as many, or it could have just said there are 10 windings on the primary side and there is 1 winding on the secondary side. So if I drew this out, it would look like 10 and 1 for my windings. If my windings are going down, I should expect my voltage to be less than we started with. And 110 volts are applied. That's our primary voltage, or our applied voltage is 110 volts. We are trying to figure out what our new voltage would be. So that's a question mark or an X. Now I'm going to erase my little drawing here so I can not mess it up with my hand. So we have our numbers here. So let's plug and chug. VS equals VS over VP equals NS over NP. And I'll remind you in the PowerPoint, they have these opposite, but I'm going to show you it's going to work out the same way. So our VS, weird, we have X on top. Ooh, crazy, but it's going to be fine. And our applied voltage, our VP is 110 volts, but if you want to make that V go away, that's totally fine. Our NS is 1. Our secondary voltage was 1. Our secondary windings, how many windings we had on the secondary side is 1. And the number of windings we had on the primary side was 10. Now we're just going to do a little cross multiplying. 1 times 110 is 110. 10 times x is 10x. And we're going to divide both sides by 10 to give us 110 divided by 10 gives us 11 equals x. What was the only difference between setting this up opposite than the way it does on the PowerPoint? Instead of 11 being on the right side of our problem, it's on the left side of our problem. But regardless, we got 11 volts equals x. If we started with 110 and we ended up with 11, it is indeed a step down transformer. So what would happen if we did a step up transformer? So let's look at that. Let's make up a problem, or let's see if we have one on our sheet here, or our PowerPoint. 200. That's a step up. Okay, perfect. On slide 75, it says, what is the output voltage, problem number one, what is the output voltage, right here, of if the primary side of the transformer is 200 turns, the secondary side is 1,000 turns, and the incoming voltage is 110. Okay, it can tell us incoming voltage, it can say voltage on the primary side, it can say applied voltage. They all mean the same thing. That's our voltage. Our voltage is the same on this one too, so we'll keep it that way. 110 is our applied voltage. What is the output voltage, our VS, if the primary side of the transformer, our primary side has 200 turns, 200 turns, and the secondary side has 1,000 turns. Boop, boop, boop. Well, if our secondary side, if we're drawing this out, has a lot more turns than this side, this is a step up transformer. So first things first, I should expect my ending result to give me a much higher voltage than this 110. That's the first thing I'm thinking here, because it's going to be a step up transformer, because we went from 200 turns to 1,000. We're going to bring that voltage way up. So let's set it up. VS is what we're looking for. If we want to do it the opposite way, actually I will do it the opposite way. Let's set it up the other way. So we can do VP over VS equals NP over NS. Either option will give you the same result as long as you know where your numbers go. I kind of like this formula better because usually what we're solving for is VS, and I like it to be in that little spot. It just makes my math work better in my head. I don't know. I just like the way it's set up. So, but you can do it the other way too. Our VP is 110. That's our applied voltage. If you want to put the V there to remind you that it's voltage, that's totally fine. We're solving for our secondary voltage, which is this guy. Our primary turns, number of turns on the primary side was 200, and on the secondary side was 1,000. 1,000 is much bigger, so again, we should expect our voltage at the end of the day to be higher or even much higher than that 110. And then with just more cross multiplication, we can do 200 times x, 200x, and this should be 11,000, I want to say. 110, oopsie, where'd my calculator go? 110 times 1,000. Let's look. Oh, I'm sorry, 110,000. Oh, duh, I could have just done that. Boop, boop, boop. Boop, boop, boop. This is why you'll always catch me with a calculator. Okay, and then we just divide both sides by 200 to get x by itself. And we're going to divide that 110,000 divided by 200 equals 550 volts. So again, we expected that voltage of 110 to be much higher, which it is. This is a step up transformer. Now, if you are a person who can recognize patterns, you could have seen that we had 5 times as many windings on the secondary side than the primary. So if you wanted to right off the bat, we could have just multiplied this number by 5 and gotten 550 if it works out very nicely. Sometimes these numbers don't feed into each other as nicely, so it's good to know how to work it out. And I always encourage, even if you looked at this and you're like, oh, it's going to be 550, I know it right off the bat, I do encourage you to work it out if you're somebody who needs to. I always do, even if it's like, you'll catch me with a calculator with like 2 times 6, and I'll have no shame in the game. So this is a step up transformer. We did a step down transformer. So now, and if you look here on that same slide, we have a question that has to do with current. The second one is talking about what happens when we change our voltage and our current. Now, for your current, we have let's see if there's extra problems there. There aren't. That's okay. Now, if we're looking for just our current, I used brown earlier, so that's what I'll use. Our current. Current is our amperage. Remember, our current is going to be what is going to make our cathode, the filament inside our cathode get really, really hot, and it's going to produce all of our electrons as they burn off of that filament. If we say cathode, if we say filament, it's the same thing. They're the same working part. That's going to be what gives us all of our electrons to start our X-ray production. We want a high current to go to the filament side of our X-ray tube. When that happens, our voltage is down. So whenever we're talking about current, we're typically going to be dealing with a step down transformer. But we can also be asked problems about, well, what happens to our current on a step up transformer? If our voltage goes up, our current would go down. So we can be asked any manner of those type of problems. Now, our formula, if we were looking for just our current, would be IS. I is going to be what our current is. I don't know why it's not a C. I don't know why it's not an A, but that's just what it is. Equals NP over NS. Now this one does matter a little bit more on how we do set it up, because if we notice, our S's are opposite and our P's are opposite. Just like on our inverse square law where things were inverse, this is the same situation. Let me move this over just a little bit so I have more room. IS over IP equals NP over NS. Our IS is our primary side, our secondary current. So this is the current on the secondary side of our transformer. So if we drew our transformer, it would be the current or the amperage on this side. Our IP would be the amperage on our primary side. So I'm just going to write current primary. And then our NP and our NS mean exactly the same thing that they did on the voltage problem. NP is the number of windings on the primary side, and our NS is the number of windings on our secondary side. So again, whenever we are talking about transformers in general, first thing, whenever we're talking about a transformer, if it says it's a step up transformer, so let's say this is a step up transformer. When we're referring to a step up transformer, the first thing we're thinking of is not current. The first thing we're thinking of is voltage, because current is an afterthought, or a current is a chain reaction. The first thing that would actually change would be our voltage. So in this case, for a step up transformer, our voltage would be higher over here, and because of that, our current would have to go down. So on this side, our voltage would be lower and our current would be higher. So on a step up transformer, we're increasing our voltage, but our current would go down. So sometimes you will be asked what happens to current based on the voltage, which is the next set of stuff we're going to go, or sometimes it might just give you information based on the current. So we don't have a problem here. Let me see. I don't have just a current problem, so let's make one up. So this one is going to be my own making. So let's say what is the applied or the output current if the primary side of the transformer has 400 turns and the secondary side of the transformer has 2,000 turns, okay? And our incoming current is 5 amperes. Okay, so this is a made up problem. So I said our primary side has 400 turns, our secondary side has 2,000 turns, and our incoming current, or the current on the primary side, the secondary side, is our, nope, you did that wrong, Sarah Beth. Sorry. We're gonna be looking for our applied current, our secondary current, goodness. And I want this to be 5. So based on what I'm drawing here, goodness, I can't draw a straight line to save my life. Good thing my life doesn't depend on it, I guess. Boop, boop. Okay, this is my transformer. Based on the things I just said, if my number of windings on the primary side, which is always going to be this side, is 400, and on the secondary side, it's 2,000. So a lot more windings over here. So I should expect this to be a step up transformer. Why do I expect that? Because my number of windings on my secondary side is higher. So I would expect if we were solving for voltage, it would be higher. But if my secondary side has more windings, I care about current. So what I should expect is that my current should go down because we have more windings on that secondary side. So what I'm looking for here, I guess I should put it up here. What I'm looking for here on my secondary side is a number that is less than the applied, because my current would have gone down if my voltage went up. So when I solve for this, I'm looking for a number less than 5. And this is going to be a true test if I know how to make up a problem and I know how to solve a problem, because I just did this off the top of my head. So our IS is our what we're solving for, X here. My applied current, which would have been on my primary side. My primary current is 5. The number of primary windings I have is 400. And the number of secondary windings I have is 2,000. So let's see if we did it. So 2,000x equals 5 times 400 is also 2,000. Right? 5 times 400, yeah. Yep, 2,000. And then we're going to get 2,000 divided by 2,000, and that's okay. Our new current is 1 amp, which is fine because that number is less than 5. So my current would have gone down. My voltage would have gone up with this combination. So if we were solving just for current, that's how we would do it. Now, whenever I give you your problems on your test, they're usually pretty similar to what you would see on your PowerPoint or on your practice problems, but you might get a wild card. So I wanted to make sure you knew how to solve just for current because there's not an example in there. And our last example we're going to do is we're going to solve a problem when we are given voltage and current. So this one here, if you go to slide 74, is going to give us a formula that says IS over IP is going to be equal to VP over VS. What do we notice here? We don't get any windings on this one. It's only about the current and our voltage. So same thing like usual, our IS is our secondary current. IP is our primary current. VP is primary voltage. And VS is our secondary voltage. And again, they're opposite. Our S's are opposite, our P's are opposite. So this problem on slide 75 says, what is the output voltage of the step-up transformer if the input voltage is 110, input voltage is 110, input amperage is 100, and the output amperage is 20. So let's take a gander here. First things first, I'm gonna draw it. What is the output voltage of the step-up transformer? So if I have a step-up transformer, I am looking for a higher voltage on this side. We don't have to deal with windings, but if we were looking at windings, we would see more of them on this side than this side. They would be much closer together, more tightly wound. What I am worried about though, or what we do talk about here, is our current. So our input amperage was 100 over here. So we had 100 amps over here. And our output amperage was 20, which makes sense because we're looking for our voltage to increase. Our current went down. The initial voltage they gave us was 110. So I'm going to be looking for a number that is higher than 110. Whoops. I'm expecting to find a number that is higher than 110. That's the first thing I'm thinking. I'm like, okay, it's a step up transformer. I'm looking for my secondary voltage right here, X. And I'm hoping when I get my math right that it's gonna be higher than 110. That's the way I do it. You don't have to do it that way. You don't have to, this is just how I double check myself because again, I'm terrible at math. So I just like to have all these fail safes in place. So if I confuse myself or if I get confused, I can look at the whole picture. So what is the output voltage, which is what we're solving for, X right there. If the input voltage is 110, so our primary voltage is 110, and even when I draw it out, I write that stuff. I write, okay, it was 110 here, and I'm looking for a number that's higher than 110 over there. If the input voltage is 110, input amperage is 100, so that's my IP, and my output voltage is 20. That should be 100 amps, and this should be 20 amps. That's my secondary. After I draw it out, and draw it off to the side on your scratch paper, whatever you need to do. Right now, I'm going to erase this because it's going to get in my way and get on my hands. So this is how I would set this up. Now, you don't really have the luxury of using different colors when you are taking your test. But hopefully by then you'll have practiced this enough that you're good to go. And I am just going to use a neutral color here, and we're just going to use this green. So my IS is 20. That's my secondary amperage. If you want to put your A there and your V's, that's totally fine. My secondary amperage was 100 because these A's are going to cancel out. My primary voltage is 110 volts, and I'm solving for my secondary voltage of X. Now we put all our numbers where they belong, and we'll just plug and chuck. Now, I like to already cross out these A's because we don't need them anymore. They're going to cancel each other out. So we have 20 times X is 20X. You can put it on this side if you want. I like to put it over there. Doesn't matter. Or I guess if we're going to stick with the way we should, that's fine. So 110 times a 100. We had this earlier. It should be 100. No, we didn't. This is a 11,000. So actually, I'm going to do it the way it's set up. 11,000 volts equals, our A's canceled out, so I'm not going to write them again, equals 20X. And then I'm going to divide both sides by 20. And you guys know I usually I would have taken the volt out, but since we're working with two different units, I kept it in just so we know who belongs with who. Our A's canceled out, so we don't have to worry about them. So the only unit we should see should be our volts. We're gonna cancel both of those out. I'm gonna bring this over here, and we have 11,000 divided by 20. What was I looking for here again? I'm looking for a voltage, and I'm looking for that voltage to be higher than 110. 11,000 divided by 20 equals 550 volts, which is higher than that 110 we started with. So this is how you would solve if you were given two different currents and one voltage, or even if you were given, we could solve for current. We can do one of those really fast. If you're bored of this, you can stop it whenever you want. But let's do one more and we'll solve for a new current. So let's say here, all right. Let's see what I want to do. I want to solve for a current, and that was a step up transformer. So I think I'm going to do a step down transformer as I set this up. And let's say we're solving for our secondary current. So first thing I'm going to do here when I'm making this problem up is I'm going to make that an X. I don't know what's going to happen. I should expect my current to go up. So let's say that my current over here, my applied current, let's say it's 10 amps. And if my voltage is going down, I should expect a higher voltage on my left side or my primary side than my secondary. So let's call this, let's call this 15, well, let's say it's 200 volts over here. And let's call this, I don't know, let's use 120 volts over here. So if I were drawing this out, I would expect this side to have more windings than this side. And my current over here is 10, and if this is a step down transformer, my voltage went down, so I should expect my current to go up. So I should expect this number to be higher than 10 if I am going to do my math correctly. My primary voltage or my applied voltage is 200, and my secondary voltage was 120. So let's set that up and see if it works. Okay, my IS, I think I'm going to use that green again. Put my markers away. Okay, IS is what we're solving for. So I am going to put the X up there. My primary current was 10 amps. My primary voltage was 200 volts, and my secondary voltage was 120 volts. My V's are going to cancel out, so I'm just going to draw a line through them. Again, this is a step down transformer based on what I just made up, so I'm looking for a number bigger than 10. So let's do 10 times 200 is 2,000 amperes equals 120x. We'll divide both sides by 120. Make sure I did my math in general right. 10 times 200 is 2,000. Yep. And we're going to divide that by 120. My 120s are going to cancel out, and I'm going to end up with 2,000 over 120 equals 16.666666. So I'm going to say 16.7 amperes. So yes, my number or my current did end up being higher than 10. And if my current went up from one side to the other, if my current from here to here was higher, current went up, what would have to happen to my voltage over here, which we already knew? My voltage went down. And whenever we're talking about transformers, we really only care about the voltage. So this is a step down transformer because our voltage was pretty high over here and it went lower over here. That is what I have for you. I really hope that helped you figure some stuff out and do some problems. If you do have more questions, please absolutely let me know. And I hope, yeah, we can see all of that. Wonderful. If you do have any questions at all, please reach out.